Okay, so here's another example we're going to work on in graphing polynomials. We're going to use those 3 steps. And so the first thing I'm going to do is I'm going to graph the x-intercepts, and we're going to find the zeros. Now in this case we already have it in factored form, so we don't need to use the synthetic division or the rational zeros theorem. And so what we're going to do is we're just going to use the zero product principle, right? So we know that this is going to be 0 when x is equal to 1. So we know we have an x-intercept at 1. Okay, we also have a 0 at 3. And we have another 0 at -2. And this is also a repeated 0. It has a coefficient, it has an exponent of 2. And so those are the 3 intercepts that we have for x-intercepts. And of course the y-intercepts, well, in the y-intercept we're going to have to plug in 0 here and then solve this. So if we plug in 0 here, we get -1, and this gives us a -3, so -1 times -3 is 3. And then this gives us 2 squared, which is 4, so 3 times 4 is 12, and then of course we got the negative. So this is going to be way down here at -12 as our y-intercept. Okay, so there's steps 1 and 2 already done, and now we're going to look at end behavior. So now, as far as end behavior goes, if it's in factored form, all we have to do is look at the degree of the leading coefficient, which means all we're going to look at is multiplying these x values. Because if we FOIL this, we're going to get an x squared here. Here we got an x, and here we got an x. So if we have an x squared times x gives us x cubed, times another x gives us x to the 4th. This is going to be a 4th degree polynomial. Okay? So again, the other way is you have 2, 1, and 1. So if you add up the multiplicities here, you're going to get an x to the 4th power. Okay? So, it's a 4th degree polynomial, so it's even, and the leading coefficient is going to be negative. So, since it's even, we know the end behavior is the tails are going to go in the same direction, and the fact that we have this negative sign here means that both tails are going to go down. And so we know that it's going to look something like this over here and something like that over here. Okay. Now, again, we can use the multiplicity to see what's going on at the x-intercepts. So again, we know it's going to cross here because this is 1, right? They're odd degrees, and they're 1, so it crosses. Even degrees, it touches. Okay, so it's going to touch at -2. Okay, so it's not going to cross at -2, it's going to touch. So it's going to bounce. Okay, so now, how can we use this to kind of gain an idea of what's going on? Well, we know it's going to come up to here, and it's going to touch. And then, so it's going to change direction, it's going to come back down, and it's got to cross through here. And so maybe it's going to come through here and then turn and come back up here, and it's going to cross at 1, but then it's going to cross at 3, so it has to turn around somewhere, come back down, and then it's going to continue on that way. Now again, you could do the table, right? You could create that table and do the test points, or you can use the multiplicities and understand that, hey, is it going to cross, is it going to bounce, or is it going to wiggle at the x-axis? At the x-intercepts. Okay, so again, it's up to you. Either way is fine. So here, what I'm going to do is, I know it's going to cross. It's going to touch here at -2 because of the even multiplicity. So it's going to go up. And it's going to go, maybe do something looking like this. And let's say maybe it does something like that. Maybe it looks something like that. Now I could plot a couple more points over here and get a better idea of what's going on in here. But again, for the purpose of sketching the graph, this would be perfectly fine. Okay? Now, if I wanted to do the table, again, have your intervals. So here we've got 4 intervals again. So we've got negative infinity to negative 2. Then we've got negative 2 to 1, 1 to 3, and then 3 to positive infinity. And then we need our test point, or our x value. So here, negative 3. Here, might as well use 0. Here we could use 2. And here we could use 4. And this is where we can look at the sign. Now, this here, this test point negative 3, this will be negative, right? And then this here will be what? Negative. Now this is squared, so this is always going to be positive. So now don't forget this negative here. Negative times negative times negative. This is going to be negative. Now what about 0? Well, 0 we already know is negative because it's the y-intercept just like before. Okay, but again, you can see it's negative, negative. Well, this is always going to be positive, right? So again, you get the same thing. Now what about 2? So let's plug in 2. 2, this will become positive. This will stay negative. Of course, this is positive. So now we get positive. And then 4, this is positive, positive, positive. And so we end up with negative. And so again, what's the result? We're going to be below, below, above, below, which is exactly what we ended up with. Okay, and that's it. Have a great day.